We're now going to go through a very important skill, and that is solving trigonometric equations, and I'm saying with a coefficient. And what that means is dealing with them when we've got like 2x. So instead of just x, we've got 2x here, and that makes the question just a little bit harder. So how do we approach it when we have a coefficient in front of our x term here? So a coefficient other than 1. What do you do? Well, what you have to do is you have to make sure that your domain is the same as this. So I need my domain to be in terms of 2x instead of just x, because this is 2x. So that's the first thing you need to know. You need this to look like this. So that means in order to get x to look like 2x, I multiply it by 2. I multiply this by 2. I multiply this by 2. So that means I'm going to get cos of 2x is equal to negative a half, but now my domain is negative 2 pi is less than or equal to 2x is less than or equal to 4 pi. Once I've done that, I just solve this as a normal trigonometric equation. So I can just solve it like a normal trigonometric equation now. So I need to figure out what my reference angle is going to be. How can I figure out what my reference angle is going to be? I draw for myself a special triangle. This is the square root of 3, 2, 1. Now I'm using this special triangle because I've been given 1 and 2. If I was given other ones, perhaps like 1 and the square root of 2, that's when I would use my pi on 4 special triangle. So you just have to make sure you know which special triangle to use in which case. This one's more likely to come up because it accounts for both pi on 3 and pi on 6. Because you know that this angle here is pi on 3 and this one here is pi on 6. Okay, now cos of what angle gives me a half out. So when you're figuring out your reference angle, you just ignore that negative and you're right, cos of what angle gives me a half out? Well, that's going to be cos is adjacent over hypotenuse, right? Well, for me to get 1 over 2 using adjacent over hypotenuse, well, it has to be this angle right here, because adjacent hypotenuse, it has to be pi on 3. So that means my reference angle is going to be pi on 3. Make sure you identify the reference angle. That's very important, and it might be worth a mark. Then we keep on going, and we need to figure out which quadrants we exist in. I like to draw for myself a little unit circle. And now I'm thinking, all right, I'm dealing with cos, so that's my x-axis, and I need to think, all right, where's my x-axis? Negative, because I've got negative a half here. So if it's cos of this, well, I think, all right, cos, I'm here, I'm thinking of that. Where is cos negative? Well, my x values are going to be negative in this quadrant and this quadrant, because that's where the negative x values are. They're on this side. So that means it's in the second and third quadrant. Then we keep on going. And now we're going to say, all right, let's list out our answers here. Now, you have to be careful because we're listing them out for 2x, okay? Because that's the 2x there. We're listing out the answers for 2x. We want eventually to get our answers just in terms of x, but for now it's 2x. Now, let's think for a moment. If I've got a reference angle of pi on 3, but my first answer lives in the second quadrant, what's pi on 3 in the second quadrant? It's going to be 2 pi on 3. The way that I memorize this is that all my angles in the second quadrant are 1 less than the denominator. So it's 2 pi on 3. If I was dealing with, this is just off to the side for a second. If my reference angle was pi on 4, then in the second quadrant, it would be 3 pi on 4. If my reference angle was pi on 6, in the second quadrant, my answer would be 5 pi on 6. So it's always 1 less than the denominator in the second quadrant. These are things that you really have to just memorize and get really good and quick at identifying. When you're in the third quadrant, which is where our other answer lies, you need to remember it's 1 more than the denominator. So it's going to be 4 pi on 3. Okay, so once we've identified these two, the next thing that we need to do after this is we need to think, all right, have I got everything I need? Because my domain is to 4 pi. Well, I've only gone around my unit circle once. I need to go around again if I'm going to account for all the answers in 4 pi. So that means what I need to do is I need to add 2 pi to both of them. Adding 2 pi with a denominator of 3 is the same as adding 6 pi on 3. Is the same as adding 6 pi on 3. So that means what we're going to get here when we add 6 pi on 3, which is 2 pi, is 8 pi on 3. What is it? That's really ugly. Let me try that again. 8 pi on 3 and 10 pi on 3. Also, look at your domain. We need to go backwards. We need to go backwards as well because I've got a negative here. And you see how, like, I automatically just left room here because I knew I had to deal with negative. So I left room here. Really important that you do that. So if you didn't do that, you're kind of like trying to squish everything there. I mean, it's fine, but I think you're more likely to make a mistake doing that. So just leave room if you see you've got to deal with a negative domain. Because now I just need to minus 2 pi from both of these. So let's try that. I need to minus 2 pi from that one and 2 pi from that one. Okay. So the way I'm thinking of it is that we're just minus 6 pi on 3 to both. That's all we're doing. That is all we are doing. Oh, sorry, and I've labeled this the wrong way around. This one will give us this one. This one will give us that one. All right, what is 4 pi on 3 minus 6 pi on 3? It's negative 2 pi on 3. What is 2 pi on 3 minus 6 pi on 3? It's negative 4 pi on 3. And you might be thinking, hey, 2 pi on 3, 2 pi on 3, 4 pi on 3, 4 pi on 3. The only reason that has happened is because we're dealing with this particular problem. That won't always happen. It won't just be the negative values of it. You have to make sure that you subtract 2 pi from them just to double check what's happening. But it will happen in some occurrences. If we think about why that's happened, if you think that's 2 pi on 3, right? So my first answer going backwards is that. Do you notice how these are symmetrical? This is obviously just going to be the same thing, but negative. And, when I go a bit more, it's 4 pi on 3, but negative. That's why it's happening. Are we done yet? No, we are not done yet. We now need to find what the x is. We need to get this x by itself. And in order to do that, you need to, and I'll grab a different color, I'll grab an orange here. You need to times this by a half. Because by timesing it by a half, you can get rid of that too. So I'm timesing everything by a half. I can't even talk anymore. Times everything by a half. My goodness, there's a lot of answers here. Okay, now this is where we want to separate the sheep from the goats here. We want to see, well, you can do this the slow way or the fast way. If you want to be really, really quick here, if you're timesing something by a half, you really just have to go, all right, that's going to cancel with that, and that's going to become 2. Now, if that seems confusing, let's just back up and do it the slow way, and then we'll see how it works. So let's just deal with the first answer here. If I times this by a half, that means I'm timesing this 2 by that denominator. This is how fractions work when you're timesing them, something that we definitely expect you to know. So that's how it works. Now, do you see how we could simplify this? I could simplify this by simply going, well, both of these are divisible by 2. That's going to become 3. That's going to become 2. So what I'm going to be left with is negative 2 pi on 3. Now, it's slow to do it each step. Like we could do to the next one as well. We could say, all right, this one's going to be negative 2 pi on 6. And then we could simplify. This is going to be negative pi on 3. Because we would simplify there. We'd go, all right, this cancels to 3. This cancels to 1. That's a long way to do it. A much quicker way to do it is to say, well, this denominator would cancel with this, and that becomes 2. So as you can see, negative 2 pi on 3, negative 2 pi on 3. Here, this 2 would cancel with this 2, so I'm left with 1 there. See how much quicker that is? So this one would cancel with that one, that would become 1. This one would cancel with that one, that would become 2. That one would cancel with that one, that would become 4. That would cancel with that one and become 5. See how much quicker that is? And when you're in an exam situation, you need to be as quick as humanly possible without making any mistakes. So I would really encourage you to get really good at this. And this is definitely assumed knowledge here. This is basic fraction work. So hopefully you'd know how to do it. There are our answers, everyone. I'm going to say that this is an extremely important skill that you must master. So make sure you spend plenty of time with it and you can do it successfully. Now, this would happen in an exam 1, wouldn't it? Because we want to see that you can do this in exam 1, but it's still important. So it's very important you can do this by hand. Extremely important. But you should also know how to do it on your CAS calculator as well. And let's just check that we've done it correctly by putting it into our CAS. So if we wanted to put this into our CAS, what would we do? We would go menu, 3-1 to solve. And then what was the question? It was cos of 2x. I would come to trig. I would go cos. I would type in 2x. I would do this. I would go equals negative a half. Then I would go comma x, close it. But now you have to remember to restrict the domain. So control this is such that, and then you put in the original one you were given. So it's going to be negative pi. Then you want to go to your inequality signs. Well, that's not an inequality sign. Control this is less than x. Control this is less than 2 pi. Our answers are, now let's come down here so we can look at our answers as well. There they are. All right, negative 2 pi on 3, negative 2 pi on 3, negative pi on 3, negative pi on 3, pi on 3, pi on 3, 2 pi on 3, 2 pi on 3, 4 pi on 3, 4 pi on 3, 5 pi on 3, 5 pi on 3, and that's it. So that's how it works. That's how you do it. You need to make sure you can do this by hand. It is extremely important. All right, I'll see you later.